What if I told you there's a factory in Europe so massive and advanced, it builds airplanes bigger than some buildings, and every single part of it moves with the precision of a Swiss watch? This isn't science fiction. This is the real-life birthplace of the world's largest European aircraft. And today we're going inside to see how one of the most complex machines ever made actually comes together. All right, picture this. You're standing on the tarmac in Toulouse, France, the beating heart of Airbus, the European aerospace giant that goes head-to-head with Boeing on the global stage. The air smells faintly of jet fuel, the kind of scent that tells you you're somewhere history is being written. In front of you is the Airbus A380 assembly plant, a structure so enormous you could fit an entire football field inside it and still have room to park a few commercial jets. This is where some of the world's largest and most sophisticated aircraft are brought to life. The Airbus facility isn't just a factory. It's a city within a city. It employs thousands of engineers, technicians, and logistics experts who share one goal: piece together machines capable of carrying hundreds of passengers safely across the globe. Let's break it down, because this isn't a typical assembly line story. The A380, for example, isn't built in a single location. Parts come from all over Europe, wings from the United Kingdom, fuselage sections from Germany, the tail from Spain, and cockpit structures from France. It's a massive international operation that runs on clockwork precision. Giant components travel across the continent aboard custom-built beluga transport planes, huge aircraft that look like smiling whales, so the oversized pieces can reach the final assembly line. Walking into the assembly hangar feels like stepping into the future. The space is spotless, brightly lit, and surprisingly quiet except for the hum of hydraulic lifts and the rhythmic clatter of tools. Robots and humans work side by side in near harmony. Robotic arms rotate massive fuselage sections into place, while engineers double-check every rivet, wire, and bolt. Every step is digitally monitored and logged. Airbus leverages advanced 3D modeling, virtual reality tools, and AI-based quality checks to ensure every millimeter is right. What really blows people's minds is the sheer scale. The A380 measures about 240 feet long, longer than two blue whales nose to tail, and its wingspan stretches over 260 feet. Standing beneath it, you feel tiny. Yet this behemoth can soar to 40,000 feet and cruise at nearly 600 miles per hour. To make that possible, engineers juggle thousands of variables: weight, aerodynamics, fuel efficiency, materials, and safety. The A380's primary structure uses lightweight aluminum alloys, while newer models like the A350 increasingly adopt composite materials such as carbon fiber. These materials make planes lighter, stronger, and far more fuel efficient, a necessity in today's competitive aviation market. The factory floor runs like an orchestra. Every team knows its cue. One group installs landing gear, another routes miles of electrical wiring, and another mounts the massive Rolls-Royce or Engine Alliance jet engines. It's not just putting parts together, it's precision timing and coordination. Even a small delay in one area can ripple across the entire operation. Safety standards are extremely high because these are passenger jets carrying hundreds of lives. Every rivet is inspected, every connection double-checked. Engineers use ultrasonic and X-ray tests to detect imperfections invisible to the naked eye. When you're building machines that will fly across oceans for decades, close enough simply isn't acceptable. Step into the cockpit, and you'll see why aviation has changed. It feels like a futuristic command center. Dozens of digital displays, integrated flight control systems, and streamlined controls create what Airbus calls a glass cockpit. Analog dials are gone. Everything is integrated to give pilots maximum awareness with minimal distraction. Each control is designed with human factors in mind. What sets Airbus apart is forward thinking. They're not just building planes, they're reimagining air travel for the next 20, 30, even 50 years. Inside Toulouse's R&D wings, teams experiment with hydrogen propulsion, hybrid electric systems, and sustainable aviation fuels. Airbus aims for a zero-emission commercial aircraft potentially by the mid-2030s. A bold and revolutionary goal. Assembling a massive aircraft doesn't happen in a straight line. The process is modular. Different sections arrive at different times and are joined in stages. First, forward and aft fuselage sections are connected. Next, wings, tail, and landing gear are installed. Then internal systems, hydraulics, avionics, and fuel lines are integrated. Once the main body is complete, interiors go in. Seats, entertainment systems, galleys, lavatories, and cargo holds. Each element must meet strict comfort and safety standards since these planes serve airlines globally, from Emirates and British Airways to Lufthansa, and Qantas final assembly is followed by one of the most intense testing regimes in the world. Engineers use wind tunnel simulations, ground vibration tests, and full-scale flight trials. They simulate worst-case scenarios, engine failures, extreme turbulence, hydraulic malfunctions, to validate that the aircraft can handle anything. It's a mix of cutting-edge science and nerves of steel. The Airbus ecosystem supports tens of thousands of jobs across Europe. Engineers, suppliers, transport pilots, software developers, and logistics specialists. Each aircraft represents not only an engineering marvel, but a vast network of human expertise. For many Europeans, Airbus is more than a company. It's a symbol of multinational collaboration and collective achievement. Despite the technological perfection, there's an emotional side to the process. Watch a newly finished A380 roll out of the hangar, and it's breathtaking. Engines roar, the plane taxis, and as it lifts off for its maiden flight, you feel the weight of decades of progress, teamwork, and imagination rising into the sky. There have been commercial challenges. The A380, once hailed as the future of mass air travel, faced changing airline preferences. Carriers began favoring smaller, more efficient twin-engine jets like the A350 or Boeing 787. Airbus announced it would end A380 production in 2021, closing a chapter but leaving a lasting legacy. Lessons learned and technologies developed during the A380 program feed directly into future designs. Today, Airbus focuses on sustainability and smart manufacturing. Production lines are being re-engineered to reduce emissions, waste, and energy use. 3D printed components are becoming standard in some areas, shaving weight and production time. AI-driven predictive maintenance systems can flag potential issues before they occur, like giving aircraft a built-in sense of self-awareness. Standing inside the Airbus factory, you're not just seeing metal and machines, you're witnessing the future being built in real time. It's a blend of human craftsmanship and high-tech automation, of tradition and bold innovation. Every rivet, weld, and line of code is a step toward safer, greener, and more efficient air travel. So whether you're an aviation enthusiast, a tech lover, or someone who's ever gazed out an airplane window in wonder, the next time you fly, think about the thousands of people, hundreds of machines, and years of expertise that made your journey possible. Inside this factory, the one that produced the world's largest European aircraft, every flight begins long, before the plane ever leaves the ground. Standing inside the Airbus factory feels like stepping into the future of flight, a place where precision engineering, human skill, and bold innovation come together to reshape how we cross the planet. The story of these aircraft is a reminder that every journey starts with imagination, teamwork, and relentless attention to detail. If you enjoyed this insider look, hit the like button, subscribe, and turn on notifications so you don't miss future deep dives. Subscribe for more behind-the-scenes stories that bring technology and engineering to life.